Welcome. The objective of this problem is mainly to practice unit conversion and also continuity equation, which you will find in the FE exam not under the math part, but the hydrology and hydraulics part and water resources. Okay, eh, let's just do it. But so assuming a flow is 40 meter cube per minute, so Q is giving as 40 meter cube per minute. Yeah. In a 12-inch diameter pipe. So diameter is giving as in 12-inch. Yeah. The velocity through the pipe is most nearly velocity in meter per second. So now it's asking you for velocity, but that is in meter per second. So here we have inch and here we have minutes. So we basically need to convert this to meter and we need to convert this to second. Okay, so how to do this? Basically, like in order to do this, like you say 40 meter cube per minute, I want to get rid of this minute. So I will say like 1 minute has 60 seconds in it. So now this will go away with this, and then I will have 40 over 60 meter cube per second, and that's like 2 over 3 meter cube per second. Yeah, that's me. Similarly here, like how to convert this. So I know, for example, that 1 foot has like 12-inch. Yeah, and I know that, for example, what do we have here? Like 0.3048 meter has 1 foot. Like 1 foot is about 30 centimeter or something like that. Yeah, that's about what it is. Something you can know. So what will happen here? Like this guy will go away with this guy will go away with this guy, and I will end up with something in meter. This guy can also go away with this guy. So I end up with the diameter is equal to 0.3048 in meter. So velocity, that's equal to Q over area. And we know that area, that is pi r square, that's pi over r is diameter over 2, d square over 2. So that would be pi over 4 d square. Yeah. So can we do this? Yes, we can do this. So that would be here 2 over 3 meter cube per second divided by area. That is pi over 4 d square, which is 0.3048 meter, and like we square this. So this guy will cancel away with this guy here, and like meter square will cancel away with like this is meter cube, so I'll get like meter per second, and then I need to solve this guy. So let me show you like how to solve this guy. So we also want to practice the precedence rule. So here 2 over 3 divided by, here I need to open parentheses. Why? Because in the denominator I have like two things, yeah, multiplied by one another. So this means that I need to open the parentheses here. Okay, then in this parentheses I will pi, this is pi divided by 4 time. Do I need a parentheses here? No, I don't. Because why? Because division and multiplications, they have the same precedence, so I don't need parentheses here. Because basically it will divide pi by 4 and then multiply by whatever here. Yeah. So time 0.3048 to the power of 2. Okay. So if I did something like this, then I got about 9.1. Yeah. Okay. So I got here. So that is equal to 9.1 1 meter per second, which is like this guy here. Okay, let's move to the next one. So this problem, what I want you to know is like to read the problem carefully and understand it carefully, and just don't get confused by it. And just see exactly understand what the problem is telling you, understand the continuity equation, and then should be okay. So in FE exam, it's a little bit tricky if you didn't understand the problem. A river has a continuous water flow of this between two bridges that are 100 meters apart. At bridge A upstream, the river has a cross-section area, so I have area A is like 150 meter square, while bridge B, area B downstream, the river has a cross-section area of 100 meter square. The increase in water velocity between the two bridges is mostly nearly. So here we assume that flow, continuous water flow, like so flow is, remember, like Q in, or like Q A is equal to Q B is equal to Q. And Q is given. Q is 10 meter square per second. So what is the increase in velocity between the two bridges? So basically it's asking me what the increase in velocity is, just like this guy minus this guy. So can we do this? Yes, we can, because we know that velocity is equal to Q over area. Yeah. So basically that would be, and Q is the same. Yeah. Q is the same. So that would be like Q over area of B negative Q over area of A. So can we do this? Yes, we can do this because Q is giving as 10 and the area of B is giving as like 100, for example, minus Q here is 10 over the area of A is as like 150. Yeah, because that's how you know the increase in velocity. Okay, so can I simplify this a little bit? Yeah, so I can get rid of this guy with this guy, this guy with this guy. Can I simplify it even more? Yes, so I can say this is 15 minus 10 divided by 150. That's 5 over 150. That is like 1 over what, 30, and that is 0.033. And what's the unit? Meter per second. So do I have this guy here? Yeah, I have this guy here. That's number A. Okay. So that is, you can solve this problem. Okay, now let's shift gear to, so I got like this here. Let's just shift gear to this problem. So like how to, this problem is important because it shows like, let's read the problem. A tank initially contains 500 liter of pure water. So you have a tank that has 500 liter of pure water. Pure water means that like mass is equal to 0 at pure water means like mass is equal to 0 at time is equal to 0. So I have 500 liter, that's like my volume, and that's the mass of this. A prime solution containing 0.2 kilogram liter of salt per liter enters the tank at a rate of 5 liter per minute. So now I have some concentration is entering at some velocity. So here I have C and here I have Q. Okay, the well mixed solution leaves the tank at the same rate. So Q, so I know like Q in is equal to Q out is equal to 5 liter per minute. So this is the information that I have. Yeah. Find, okay, as we'll mix the solution. Yeah. So the concentration inside like the tank would be uniform basically. That's like the concentration inside this tank will be uniform. because that's what it is. Find the differential equation for the amount of salt at the tank at the time. So here I want to see like mass as a function of time. I want to find what is the relationship between mass as a function of time. So I want to see like this is like time here and this is mass. So I want to see like how mass will like increase with time. And so it starts with zero. I know it starts with zero, but like at different time, what would be the concentration inside like this guy here? That's basically what it's asking me for. So how to do this? First, we need to see the rate of a change in mass. Like formulate this differential equation, then we solve it. If we solve it, this differential equation, we will know mass as a function of time. So this is basically a differential equation for the amount of salt in the tank at the time, and then the amount of salt in the tank after 10 minutes. I can know like after 10 minutes and after like 1 million minutes, like that. And then the limiting amount of salt in the tank as time approaches to infinity. So from 10 to infinity, like what would be the mass? Yeah. And I know that this from experience, previous example, that would be like an exponential function that will just reach like a plateau like this. Yeah. So what is this plateau basically? Yeah. It will reach like a plateau, something like this. But anyway, let's just formulate our differential equation. So basically I want to see the mass mass rate, like how mass is changing in time. So what I'm looking for is mass rate, like how mass is changing with time. That is equal to what? That's equal to the rate the salt is entering, like m. Remember, like m, that's like m over t. So the rate salt is entering in uh, minus the rate salt is leaving. Like, so what is entering and what's coming out, that will tell you what is changing inside. Remember, like the laws of conservation, what's entering through your boundary is what's changing inside your volume. Yeah, mass in and mass out. Okay, like what is mn? We know this guy. Yeah, this is given. So the mass in, that is like 5 liter per minute. Yeah, and each liter has zero point 0.2 kilogram per liter. So liter will cancel with the liter. So I will get 1 kilogram per minute. That is the M in. What is the M out? So the M out, this is giving, so 5, because here Q in is equal to Q out is equal to 5. So this is LM. And what is the concentration that's leaving? That is basically the concentration here is changing because it's like M over volume, mass, or like the mass over volume. So the volume is giving as like 500 liter. Yeah, so mass like this is like in kilogram and this is in liter, mass over, and this is changing with time. So I don't know this. Yeah. So basically, so this guy will go away with this guy. This guy will go away with this guy. So I will get like M over 100 kilogram per minute. And this M will start as 0 and will keep increasing up to a limit which we will know. Like that's exactly what we want to find. Like what is this limit? Yeah. So start at a 0 and it keep increasing to a limit. Okay, so now I have my differential equation. dm is equal over dt, that is equal to mass in 1 minus m over 100. So I answer the first part. Find the differential equation of a salt at the tank. So now this is basically telling me the rate of a change of the mass. Yeah. Now, in order to answer the second part, like which is this is just the rate of a change, but I don't want the rate of a change. I want mass as a function of time. Like as time change, how will my mass change? So I need to find like a relationship between mass and time. So how to do this? We know how to do this. We just like integrate like this guy. That's like how to do this. And we know how to integrate like differential equation. Like we know how to solve like this differential equation. So let me just arrange this guy a little bit. So that would be like 100 negative m over 100. Yeah, over 100. And let me just put it here. Let me just do some arrangement. So I will say like 100 over 100 minus m dm. I will just bring this to like this side here, and I will bring dt to this side here of dm that is equal to dt. Yeah. Can I do more arrangement? Yes, I can do more arrangement. I can say like 1 over 100 m dm is equal to 1 over 100 dt. Yeah. So now, like to find the relationship m as a function of t, I just need to integrate both sides. Yeah, both of these guys. So I integrate this with, I integrate this with respect to m, and I integrate this with respect to t. This is a constant, so basically I can do something like this. So yeah, and we know how to do this. We practice a lot of calculus before. That's why we took several modules in calculus, so that when we come to this stage, we will know how to do this. Yeah. So does this look to me something I know here? Yeah. Do you remember we had like the integration of a derivative and its function that is equal to ln of this function. Except here I don't have a function of x, I have a function of m. Yeah, so this guy would be m, and this guy would be m. So my function is, yeah, my f of m is equal to 100 negative m. What is the derivative of this function? Now you are expert in this, yeah? That would be, this a constant would be 0, that's like 0, and that would be negative 1, yeah? Okay, so now I have like a function, yeah, and it's derivative, except that I don't have negative 1 here. I just have 1, yeah. So how, okay, but that's not a problem, because can I just put like a negative 1 here and I put a negative here? Because like negative times negative, they will cancel out, so it doesn't hurt, yeah. So now in this form, I have like, this is the function. So this is f of x, and that is the derivative of the function f of m. Sorry. So the integration of this guy will be this guy here. Yeah. And I put a negative here. I can even get rid of this negative. Instead of putting it on this side, I can just put it here on this side. Okay. And now I have something that looks like this. So I know how to integrate this guy. That is easy. So that would be like len, my function, like this guy. So len 100 m. I know how to integrate this guy. That is basically would be equal to t. So that is equal negative 100 times t plus some constant here. Yeah. So I'm good. Yeah, I think I'm good. I have an equation. I know that I don't like to see this as a len. We usually like to see this as an exponential function, not as a log function. So I just multiply both sides. I raise both sides to. So here I will have len. Yeah, that is equal to e to the power uh, negative t over 100. Yeah. And then here e to the power c or whatever. Yeah, to the power c. Okay, so now I know this guy. Yeah, that's just equal to here. It's cancelled, so I will get here 100 negative m is equal to, this is just a constant, so it really doesn't matter. This constant could be anything, so I can just call this k. Doesn't really matter, so I will just call this k because it's a constant. Yeah, it could be anything, so I will call this k e to the power negative t over 100. So I got an equation that looks something like this. So now I'm almost there. Remember, I need m of t. I just need to rearrange these terms. So I can say like m is equal to, so I bring this here 100 negative k e to the power negative t over 100. Can I find this constant? Yes, I can find this constant because remember I have a condition here. M is t is equal to 0, m is equal to 0. So I have a condition here. T is equal to 0, m of 0, like when t is equal to 0, that is equal to 0. So I can just substitute here. So m is equal to 0, that's equal to 100 negative k e to the power, this is e to the power 0, so e to the power 0 exponential of 0, that will give you 1. So k would be equal to 100. Okay, so now I have k is equal to 100. Yeah, and let me show you like exp of 0, that's equal to 1. Yeah, so k is equal to 100. Yeah, and so now I can just substitute it here in my equation. So I can say like m is equal to 100 negative k is equal to 100 e to the power negative t over 100. I can take this as a common factor, so that would be 100 1 minus e to the power negative t. Wow, I'm done. I have now an equation between mass as a function of time, which I can just plot. And I see here it's an exponential function or something that I can. So let's just answer the questions that we have, because now we can answer these questions. Yeah. So it is asking me the amount of salt in the tank after 10 minutes. That is not difficult. So after 10 minutes, at t is equal to 10 minutes. So here m of 10, that is equal to 100. 1 minus negative 10 over 100. So I can do this with Excel, for example. Let me just show you like how to do this here. So you come here to Excel and you will say like equal to 100 times 1 exponent of negative 1 over 10 and close the bracket. So if I did this, I got about 5.2 maybe. Yeah, again 5.2 kilogram, 9.5.2 kilogram. Yeah, is this correct or no? Yeah, 9.2. So that is this question. Now it's telling you the second part, or like the last part of this problem is telling you the limiting amount of salt in the tank as t approaches infinity. So what would be the limiting amount as t approaches infinity? So t is equal to infinity. So m of infinity is equal to 100 negative 1 minus infinity over 100. So infinity over 100, infinity over anything, that's like infinity. So negative infinity basically. Uh, so what is e to the power negative infinity? E to the power negative infinity, that's zero. But like, how could you check this? You can use like Python, for example. So let me show you. Like, if you come here, uh, because I checked this, it's not like in Excel. You cannot do it, but you can do it with Python. Python Jupyter Online, so you can just, you don't need to install Python. I have Python installed, but I just want to show you like that you don't even need to install Python to use Python. See here, I can open a new notebook or whatever, and then like I want to check, what do I want to check? I want to check e to the power infinity. So I can say here, import the math library, for example, math. And then I can come here, say like mass dot x. Like if you click here, it will tell you, like you click tab T on your keyboard, it will tell you like what are like, so you see here exponent. And then I want to find like the exponent of negative infinity. So negative, and then math, put like I, and then you see here you have infinity. Yeah. Oops. I'm just calling like math dot infinity. Oops. I just type it here, math dot infinity. So if you did this, now not infinity, negative infinity, so exponent of negative infinity. If I did this, see, I got 0. Exponent of infinity, I think that will be infinity. That's infinity. But exponent of negative infinity, uh, that would be something like this. Okay. So let's now, so that is 0, yeah. So I know like, so that would be equal to, so this is like 0, so 1 minus 0, so that's equal to 100 kilogram. Okay, so basically, so your concentration will, should look something like this. So that's like M and T starting from 0 here and up till like 100 kilogram. Okay, so you have a homework problem, try to do it. That would be very good practice for you. Don't just like, I mean, so that's your homework problem is exactly the same except like these number change, but like the procedure is the same. So I highly encourage you that you just solve it as I did here and try to also use your calculator or Excel or whatever. Okay, so that is all for this, and see you in the next video.